Okay, so equilibrium position for electric field and force. It's the position where electric field net and force net is equal to 0. So we have two cases. First case, when we have two charges of the same sign. So let's say that this is Q and this is 4Q. They are separated by a certain distance, which let's call it as D. So the equilibrium position will be inside between them and closer to the smaller magnitude. So in our case, we have a Q which is smaller than the 4Q. So we call this distance as X, and the remaining distance, it would be the remaining portion of this, so D minus X. The other case where we have, which is if we have two charges of opposite signs. So let's call this as Q, let's call this as minus 4Q, and they're separated by a distance of D. The equilibrium position over here will be outside and closer to the smaller magnitude. So as you see, the smaller magnitude, which is Q and not the minus 4Q, we look at the magnitude only, which means absolute value. So it will be outside and closer to Q. Let's do two examples to find the equilibrium position. So I'll take this example, I'll just add some values into it. So let's say that this is again Q, this is 4Q, and they're separated by a distance of 5 centimeters. We're looking now for the equilibrium position. So now we call this distance as X, and this distance we can call it 5 centimeters minus X. I'll solve it in centimeters, then I'll change my answer to meters if I need to. Then you do the following. You use the equation for electric field from each charge on that point P. So for Q, it is separated a distance X from P. So we say that K times Q over X squared should be equal to K times 4Q over 5 minus X all of it squared. Then we start cancelling similar terms on both sides. So K is cancelled with K. Q as a variable is cancelled with a variable Q. So we are left off with 1 over X squared is equal to 4 over 5 minus X all of it squared. Then you need to get rid of the squared, so you use radical for both sides. So radical 1, which is 1 and it's over X, and radical 4, which is 2 and it is over 5 minus X. Next step, we do cross multiplication between the terms. So we will have that 2X is equal to 1 multiplied by 5 minus X. So 1 multiplied by 5 minus X. So we distribute now the 1. So it will be 2X is equal to 5 minus X. We take the X to the other side. So we will have 3X equals to 5. Then we divide both sides by 3, so X is equal to 5 over 3, and the unit is centimeters, which is equal to the following: 1.66 centimeters. Now let's do the same example but with opposite signs. So again, this is Q, this is minus 4Q now, separated by the same distance, which is 5 centimeters. So now, since they have opposite signs, the equilibrium position will be outside. Then we say that kq over x squared should be equal to k 4q over, what's the distance from 4q to this point P? It is 5 centimeters plus the distance x, so it would be over 5 plus x squared. Again, we cancel similar terms, k and k cancelled, q and q is cancelled. We have 1 over x squared is equal to 4 over 5 plus x, all of it squared. Then we do the same thing, we take radical for both sides. So we have 1 over x is equal to 2 over 5 plus x. Then we do cross multiplication. So 2x is equal to 1 times 5, which is 5, plus 1 times x, which is x. Now we take the x to the other side, so we have 2x minus x, which would be x is equal to 5 centimeters. So it is 5 centimeters to the left of the charge q. I'll do one of the examples that are in the worksheet. So we have this example, a charge of -6 and another one of -3. Since they have the same sign, it means that the equilibrium position is in the middle. So -6 times 10 power -9 coulombs, and the other one, which is -3 times 10 power -9 coulombs. They're separated by a distance of 60 centimeters. So again, since they have the same sign, it means that the equilibrium position will be in the middle. This is x, and the remaining, which is 60 minus x. Now we say that k multiplied by 6 times 10 power -9 over x squared is equal to k multiplied by 3 times 10 power -9 over 60 minus x, all of it squared. Now what is cancelled? We cancel k from both sides, times 10 power -9 is cancelled from both sides, so we are left off with 6 over x squared is equal to 3 over 60 minus x, all of it squared. Now take square root for both sides. So we have a square root of 6. Let's calculate it. Which is 2.45. So 2.45 over x is equal to, it's equal to 1.73, which is the radical 3 over 60 minus x. Now what do we do next? We cross multiply. So we have 1.73x is equal to 2.45 times 60 minus 2.45 times x. So 2.45 times 60, which is 147, minus 2.45 times x, because we need to distribute the 2.45 on 60 and x. Now we take this to the other side, so it would be 2.45 plus 1.73, which is 4.18. Then we say that x is equal to 147 over 4.18.